All right, we've got one more example, and this one's a bit abstract, but we're essentially looking at a function for a parabola, okay? But we're not actually given the numbers a and b. Now, normally you've probably recognized this equation as a quadratic, and the graph of it is a parabola. And normally we've got some numbers in here. A might be equal to 2, and b might be equal to -6, or something like that. And then you can graph the parabola. But we're just looking at a generic function for a parabola where those constants are just a and b. But just keep in mind that those are constants. They're just constants. Treat them as if they could be 2 or 8 or 16 or whatever. Okay? And so we want to find the constants a and b so that the minimum of the parabola is at -1, 4. All right? So we're trying to find this quadratic that has a minimum at -1, 4. All right, so let's start by just making a little graph of what this has to look like. All right, so if I were to graph this parabola, right? Well, actually, let's make the axis a little farther down. So -1 would be the x-coordinate, and 4 would be the y-coordinate, right? And so really, I've kind of drawn this too high, but the parabola has to open upward, right, in order for this point -1, 4 to be a minimum. All right. And so that's telling us, well, it has to be concave up, and the function has to go from decreasing to increasing at that point. And it also tells us that the derivative has to be 0 at that point. So let's first start by just taking this generic function for the parabola and finding the derivative of it. Now, even though we don't know a and b, we're just going to treat them, they're just constants. We know that they are constants. Derivative of x squared is 2x. And the derivative of ax, since a is just a constant, then it's just going to, this derivative of ax is just going to be a. And then derivative of b is just 0 because it's a constant. All right, so now we know the derivative, and we know that the minimum is going to occur when this derivative is equal to 0, right? That's going to be a critical point. We know that when x is equal to -1, this is going to be a critical point. So really, I want to evaluate the function at -1 because I know that's where the critical point occurs. And so I'm just going to take -1 and put it in for x. I don't know a. That's what I'm trying to find. And I want to set that equal to 0, right? Because I know if I have a minimum at -1, 4, right, then that has to be a critical point, and the value of the derivative at -1 has to be 0. All right. So basically, I have -2 plus a equals 0, so a has to be equal to 2. All right. So I found a. That's the first step. Now, I also know the value of the function. So if I evaluate f at -1, right, the original function now, I'm going to go back to the original function. I know a now, and I can plug in -1. So I can get -1 squared plus a, which is 2, times x, which is -1, plus b has to be equal to 4, right? Because that's the value of the function. That's what this coordinate means. That's the value of the function at -1. And now I can find b. All right, so I basically have 1 minus 2 plus b equals 4. So let's do a little algebra. I can add 2 to both sides and then subtract 1, and I get b equals 5. So that's all I need to do. Now I know the constants a and b are 2 and 5, and I could actually write the equation now for the function if I wanted to. It doesn't really ask for that, but so the equation of the function would be x squared plus 2x plus 5. And that function would have a minimum at -1, 4. All right, so that's all I have for the lecture today, and I'll meet you in class to work on the discussion questions.